Okay, so let's get started. Welcome to the monthly community meeting. And so we have 3 items on the agenda today. And the first one is how to use crun to manage WasmEdge and its plugin. As you know, the WasmEdge plugin system has a major upgrade in the previous release, which is 0.12, and also in this release 0.13. So that allows us, to add a lot more functionalities to the runtime, and we want Kubernetes-based systems to be able to manage those. And that's so in order for that, we would because we are integrated with crun as the base layer of Kubernetes, and this allows us to be managed by system like Containerd and CRIO, and then Kubernetes on top of that. So adding plugin capabilities to the runtime that's bundled with crun, and also later with run WASI, is one of the major goals for our making those plugins widely available across the ecosystem. So I asked Hydai to present on this topic first, and then I'm going to present a project Mr. Yuan has contributed to the LFX mentorship program, which is Mediapipe-rs, which is to take a collection of TensorFlow-like models that are widely used in the Google Cloud, and make them run in WasmEdge through the WASI and plugins. A lot of work has been done in that area. So that's I'll do the demo and do the presentation, but this is not just to be clear, this is not my work. This is a contribution from Mr. Yuan, and I believe he's also in the meeting. But if you have questions, you can ask me. And then for the last item on the agenda, Hydai will come up again and introduce new maintainers that we have nominated for our community. So Hydai, please go ahead and start with the first item. Use crun to manage WasmEdge and its plugins. Thank you.
Okay. Hello everyone. Can you see my screen? I believe this is a Chrome browser.
Yes.
Okay, great. So I'm going to talk about an alpha preview of the WasmEdge plus the WASI neural network plugin. We are using the TensorFlow Lite here, and so you can use the Podman and crun, to build a Wasm container image, which contains the Wasm application, contains the WASI NN plugin, also the related dependency and model files, and all of that. Then use Podman to execute it. So because this is a very alpha preview of this integration, so you will go to the link I provide in next slides, and if you want to try it, you may need to modify some patch to to load the different plugins. So the agenda is that we will have 4 steps. The first one is talking about how it works. Okay, so please notice that this is an alpha preview, so the implementation details may change. So if you encounter any bugs or any problems, just raise an issue on the GitHub issues. Okay, so we will have 2 parts have to modified to enable this feature. Let's say for the crun part, and actually in the previous integration, the crun provide several Wasm handlers. So if your container image contains the Wasm application, the crun will try to load the image and try to run the application.wasm or your wasm applications in the container image. Okay, so with this modification, actually, we just enable a new function from our C API, which is called plugin load from path. You can give a path here and ask the crun, to execute the wasm handler with trying to load this plugin. So, we just add one patch here. And how about the doc file? The previous doc file, the only thing you need to do is just add your wasm file or your input file or anything you want, anything you need in the application runtime. But with this, technical preview, you will also need to add at least two external files here. The one is the WasmEdge plugin. Depends on which backend you want to use. For example, we are using the TensorFlow Lite here. So you have, to download the WasmEdge plugin with the TensorFlow Lite enabled. And then you have to put the TensorFlow Lite dependencies into these Docker files. After that, the crun will try to launch this application image and run your application with the given plugins. So the first thing is that let's go to this branch here. And all you need to do is just add this function here. And you can change this path to anything you want. If you are, you have another plugin, maybe called the plugin XYZ, then you just change here to, plugin XYZ. Okay. So let's go to here. Okay, this is the crun. This is my fork. Because we are still, still in development. So this is temporary. I will still keep this branch. So I will not delete it. So you can always try to reference to this branch. Okay, but the commit may change. If I modify something and I do the force push, the commit may change. However, the branch will still keep here. So in this commit, you can just ignore with the default path because we want to try to use the specific path to make sure that no one the only whitelist will be loaded. Okay, if you are using with default path and you can put several maybe not in the whitelist plugin in the folder. Okay, so we just go with the plugin loader from path first. So you have to define this signature and use the DL symbol, to open this function. Then check if this function is here or is not found. Okay, then all you need in crun is to trying to load from this path. Okay, because crun will create a sandbox for the wasm handler. So this root path actually is located in your Docker image. In your container image from the root folder and the plugin location. Okay, so after that you can create a crun with the plugin support. And I also provide a Docker image here, and which is you can find here. Use the tests WasmEdge build and dockerfile.crun. If you want to try to build it by yourself, you can do this. Or I already published this Docker image on the Docker Hub. So you can just do the Docker pull Hydai crun plugin v1. If I change something, this will go to v2, right? So the first thing is that let's try to pull the image here. Okay. And let's run it. please make sure if you are using Docker in Docker or something like because you are trying to run partname and crun inside a Docker. So you may need this this privileged mode enabled. Otherwise, you may get some errors, something like you don't have such permission to modify some crun rules, something like that. So please make sure you have enabled this mode. Okay. Then let's go back to the final slide. Okay. So the next part is how to create a container image contains all of these files and execute it. So before the plugin enabled, all you need to do is from the line 4, to line 7. You just need to put your application version, put your model, put your input files, and how to execute it. Okay. However, if you want to use plugin, you have to here the line 3. You have to add the lib WasmEdge plugin wasmn.so, the shared library, and the lib TensorFlow-Lite shared library. Okay. After that, we also create a Docker image and publish to the Docker Hub. So if you don't want to build it from source, you can just use my Docker image. Otherwise, you can just follow, I put the link here so you can follow the guide to build your own container image with the application you want. Okay. So in this demo, actually, I just trying to, inference this picture and say, hey, what kind or what's the name of this bird? Okay, so the file here, you can find that I put the bird JPEG here. Okay, so let's copy the how to execute here and paste. Okay, so first thing is that I use the partname and to specify the runtime to use the crun. Okay, if you are not specify the crun runtime, maybe you will use runc or other runtime, then you will get, hey, sorry, I cannot execute the Watson architecture because in other runtime they may not implemented the Watson support. Okay, so please make sure you have used the correct runtime. And the remaining thing is pretty easy, just like you are trying to run the with Docker run, right? So the partname run, you have to also specify the platform is the WASI/Watson and the Docker image here. Okay, and how to run it. This is the Watson application, the first argument, and this is the model itself, the second argument, and this is the input file, the third argument. Okay, so let's just put it. And if you are trying to run the first time, you will try to pull a file and you will see an error here. So one thing is that, hey, you will say the PID is not available or something that is not ready, the device or resource is busy. Just wait a few seconds and try again. Okay. And after you try again, you can find that the model is loaded. So this is how the model information, you can see the size here. You can see, hey, we are trying to load the photos with the ID 0, and we are inference the picture and give you the top 5 answer of this inference. And also you will receive, and here is a malloc error. We know in this technical preview, maybe some of the WasmEdge plugin, we are not handle the malloc stuff very carefully. So here is a bug here, and we are still, figuring out. However, if you are trying to use other plugin, maybe not the WasmEdge, it should be fine. So yeah, you can go ahead and try how to, combine your plugin with the crun and with the container images. So here is my first presentation to talk about the alpha preview of the WasmEdge plus WasmEdge plugin in containers we are using crun to do that. Okay, thank you. So that's my first presentation.
All right, thank you, Hydai. Yeah, that's so this is done with with the crun setup. We are really looking forward to have the same thing available on run WASI, so that we have that in Docker as well, in Docker and also in containerd, so that those users would be able to do plugins. So just a quick note, why do we need to do those plugins? We have seen a lot of demand for people wanting to do lightweight AI inference, from our community. So if you think about that, how do you do inference today? A lot of people just use Python, right? So you use Python to train a model, and then you use Python to do inference. The problem with Python is that if you put that in a container, it drags in a large amount of dependencies. So it's not unusual to see, say, a PyTorch or TensorFlow image that is several gigabytes, in the image size, right? I've heard that it takes minutes to start up, and also takes a lot of disk space, takes a lot of memory, takes a lot of, it's just a very heavy weight. And with WASM, we were able to reduce that to tens of megabytes. So instead of Python calling PyTorch, we have WASM calling PyTorch, and and inside that WASM, you can still use Python. That's and VMware is building. That's a Python runtime. They have already built a Python runtime, and they're building a lot of those machine learning operators in that as well. But you can also use Rust, which is the thing we're gonna show in a minute. That's gonna dramatically speed up those AI inference tasks, and also make it 2 orders of magnitude smaller than, say, a regular container image, right? So yeah, that's so let me share my screen and show you. So let's first get started. Because Hydai just talked about how to do the how to add plugins in a Kubernetes environment, right? So what are the plugins that we have available, right? I guess that's the question. He has demonstrated TensorFlow Lite, but there's actually a lot more. We have a TLS plugin, which allows the WASM applications to make HTTP, to make HTTPS calls. Of course, we have seen WASM applications relying on the host to make HTTPS calls, but with the TLS plugin, the WASM application would be able to make asynchronous HTTPS calls. That means you can just use the Rust Tokyo framework with no additional APIs, and all the calls would be asynchronous, meaning you can, on one CPU, you can have hundreds of concurrent calls, and just waiting for them to return, and whoever returns, it goes ahead and process that, so the IO will not be blocking. So that's one of the things where we see those type of IO intensive applications in the world of serverless function or plugins, and things like that. And then we have WASI plugins. I think Hydai has mentioned TensorFlow Lite, but we have that with PyTorch, we have that with TensorFlow Lite. We haven't put here, we have that with regular TensorFlow as well, and we have that with Intel's OpenWino. So there's a variety of different backends that you can use to do AI inference with a variety of front-end languages, ranging from, like I said, from Python, JavaScript to, perhaps more relevant to us, Rust. That's, and we also have things like the WASI crypto plugin, and there's a lot more. We're working on the WASI logging plugin. We are turning the entire WASI, the WASI host functions into a plugin as well, so that You can have different operating systems, and you can have things like that. So all those are the plugins that you can install with our runtime. So I think it's really important for cloud native users in a Kubernetes or Docker environment to be able to use those plugins with our runtime. So that's the first point I want to make. And so then let's get to the main topic of of my part of this session, which is let me see. Come on. Okay. It's a Mediapipe-rs. And again, this is not my work, but it's a work from Mr. Yang Bo, and I think his GitHub name is here, Yang Haiku. He's our intern from the AFX mentorship, and he has done, as I'll show you, he has done a tremendous amount of work with this. So let's take a step back to say why this work is necessary, right? With WasmEdge, we have already seen, we can do AI inference. That's great, that's so what, right? That's but AI inference, the part that TensorFlow or PyTorch performs is actually a very small part, because all those framework does is that you have an array or a tensor, array of numbers. It's called a tensor, right? And you pass that to PyTorch, and it runs that on the CPU on GPU, and give you another array of numbers. That's what it does. It's up to the program to first transform whatever the application data into that array of numbers, and then transform the tensor, the array of numbers you got from PyTorch or TensorFlow back into something the application can understand. So that is called pre-processing and post-processing. And those are typically CPU tasks, and they typically constitute 95% of the inference work. So when you do AI inference, you are the most of your time actually spending on transforming the application data into those array of numbers and then transforming them back, right? So just to have WasmEdge is actually not enough, because Python has a very large ecosystem that allows you to do those transformations. And that's also part of the problems people have with Python, is that very slow. That if you do that in Python, it's really slow. That's so that's where Wasm and Rust can really help. It can speed up the post-processing and the pre-processing by orders of magnitude. Actually, that's one of the if you look at the AI and the machine learning community, this is one of the major issues. That's why Chris Latner, who's the inventor of LLVM, created a new language called module, right? It's similar to Python, but it's 10,000 times faster. It's to speed up this process, right? So, as we established, that's the major part of the work is actually to get data into the model and then out of the model. In order to accomplish that, we have to build a similar ecosystem in our in the Wasm and Rust community in order to make those type of work easier, right? So we chose a very popular set of models, which is called the Mediapipe. Mediapipe is a collection of models that Google has, I think curated. I think it's also trained in Google, and they made it available on the GCP, the Google Cloud, right? And so the idea is that for a lot of common use cases, like when you have a stream of images, when you have a stream of videos, when you stream of audios, when you have a stream of text, it would be embedded into the processing pipeline and be executed as you receive those data, which in my opinion is very similar to the serverless use case that Wasm is so good at, right? When data comes in, you trigger a serverless function, which happens to be Wasm, and it starts up really fast. It doesn't take a minute to start up. It takes some milliseconds to start up, right? And then you process that data using some of the AI models and then come back. So to get those models working, I think is a very important first step in the the AI and machine learning adoption for WebAssembly, right? So Mr. Yang worked on those models, and there's a collection of models, and you know, as I said, he has done tremendous amount of work. You know, he get most of them working. You know, that's it's you know, it's the internship is only three months. We you know, so there's still some finishing work, but I think, you know, the bulk of the work has already been done. So most of the work works. And so what I'm gonna do is that I'm gonna you know, you can go through this tutorial, but what I'm gonna do is that I'm gonna show you the whole process. And the way I'm going to show you is through GitHub Actions, so that you can easily reproduce it yourself. You don't have to, you know, install PyTorch on your computer, you know, stuff like that. You just do it on GitHub, just fork this repository, and then run it on your own. And so that's, let me, okay, how do I move this around? Okay. All right, let me switch to this tab. And what I'm gonna do is I'm gonna start rerun those jobs, because it takes about 13 minutes to run all of them. So while we are looking at the logs, I'm gonna go through them, and come on, why it's so slow? Okay, let me show you the logs first. You know, the GitHub action. The GitHub action consists of a series of scripts that are run in order. So the first is to install and initiate the Rust toolchain, which is, you know, standard. You know, everybody does that. You know, I think everybody on this call at least probably have done this many times. And then the second is to install WasmEdge, which I'm going to show you how to install WasmEdge with a TensorFlow TF-Lite plugin, because all those models that's included in this demo is TF-Lite, you know. So you know, you can also do this with PyTorch, of course, but it's just this GitHub action is TF-Lite. And then because the models are fairly big, you know, they're not large language models that's gigabytes in size. So those are you know, like BERT models and, you know, image recognition models, you know, that's a couple, you know, tens of MBs, right? You know, so it's we don't include that in the source code repository, because they're basically artifacts. So we download them from a file server, and we also download the test data from Google, because a lot of those test data, you know, we believe they're copyrighted by Google. You know, like test images and, you know, things like that. So we download those from you know, from Google server to do the test. And then there's a very interesting script which I'm gonna show you when we get there, is to put the FFmpeg dependencies. You know, FFmpeg is a very widely used image processing library. You know, that's for instance, if you have a video, you want to take a frame out of it, it's you know, you can use that to do that easily, right? You know, so it has a large number of video and image manipulation tasks, and we already knew it can be compiled to Wasm. So it's a C++ based library, and you can compile it to Wasm. And we made, and people actually use it in the browser. You know, that's to do video processing in the browser. And you know, there's numerous attempts to make it compile to WASI. So we also did that. We made it, you know, to make the necessary change to make it compile to WASI. However, you know, to have that run inside Wasm is still a little bit slow, because I believe FFmpeg can do a lot better as a native library, because it can use the multi-thread features of the CPU, and it can also potentially use the GPU. And while inside Wasm, you can do that. So so in the near future, we're also thinking about turning that, and also turning the OpenCV library into a WasmEdge plugin. And going forward, all those WasmEdge plugins going to be compatible with component model as well, so that we can you know, we can describe the interface between WasmEdge and the plugins using a WIT file, right? You know, so that's the direction we are going. So but at this moment, we are compiling the C++ source code of FFmpeg into Wasm to be used in the pre-processing and the post-processing, as I just described, for those images, right? You know, so that's you know, that's the FFmpeg. And then the last script is to run the cargo test, right? So I believe it's is that why it's not running? Okay. Okay, it's running. Oh wow. Okay, so it goes fast. So it first installs the curl and the Rust. Let me show you what it did. So so there's the scripts here, and the first is to Rust init. It's standard. That's you install the curl package, then you install run the Rust installer, and then add the WasmEdge target to the Rust installer. And then the next you do the WasmEdge init, which I think is slightly more interesting. It's I think it's download WasmEdge with TensorFlow Lite. So there's numerous ways you can do WasmEdge. It provides ways for you to compile WasmEdge from the source code, or you can do that from the release. So I think this part from the line 35 onward is to how to install it from the so it's to install it from the release files. So basically you install the WasmEdge runtime itself, and then you download the plugin, and then you unpack the plugin and then put that into the library directory. But that's not enough, because that's just the WASI plugin to WasmEdge. It doesn't actually have TensorFlow Lite itself. It only has a TensorFlow Lite interface. So what you do is that you have to download and install the TensorFlow dependencies itself. And this is basically just we packaged WasmEdge so that it has a correct version of the TensorFlow Lite library, and we make that into two files. The C file and the flex file, and just to copy them into the your library directory. And we have a new installer that would be able to automatically perform all those functions. That's you would just say install WasmEdge with the TensorFlow Lite plugin. It would install that plugin file and also the dependency files from that plugin, right? So so that's would be once you do those two steps, it will be complete install the WasmEdge. It's the TensorFlow Lite plugins, and then the TensorFlow Lite dependency itself. And then you have FFmpeg dependency in it. So that's our adaptation of FFmpeg to make it compile to the WASI target. And so basically we because we are building it with the rest of our Rust project, so we're downloading those files into a special directory, and then in the build.rs to specify that's the compiler we need to use to build those C++ files into the Wasm binary as well. So that's so this is installing the FFmpeg dependencies. And then of course there's download models. That's basically we go to Google and download all those models that they published as part of the Mediapipe library, or Mediapipe what they call model garden, right? So that's and then download test data, which are just a bunch of images where audio files, video files, where you can test all those, right? So let me see where the CI, I don't know why it's okay. So now it's testing. So so it's, let's see, it's installed Rust. It installed WasmEdge, TensorFlow Lite plugin, and then TensorFlow libraries, dependency libraries. And then it downloaded models. It's downloaded the images for test. And now it's testing with it. It's installed FFmpeg, and now it's testing. So that's where some of those tests runs fairly slow, because like I said, compiling FFmpeg to Wasm is sometimes slow. It's that's why we are looking to turning FFmpeg into a component, into a host function component. But that's for later. So if I go back to the README files, you would be able to see the results. I want to show you where Mr. Yuan has wrote about the code and the results, right? So let's say image classification. As you can see, it's actually very simple. You import the Mediapipe-rs library. And why do you need to import that crate? Because it has, again, the pre and post processing functions that built in. So what it does is that it build an image classifier builder, and then you just run that with, say, an image from a file, and then it would say give me 3 results, right? So those are the parameters that you can tell the model, or you can tell the model runner, and now you can say give an image like this. It would tell you, that's what's in that image, and the score, that's which essentially is the confidence level, and the index is the number that's associated with output array, right? So that's it's a very straightforward image classification task in less than, I would say, 12, 13 lines of code. That's it's not done by Python, and done by use Rust programming language, and can do it, and we can do it a lot more efficiently. But perhaps a more elaborate or better example is to say object detection. So you have a picture like that. You have 2 objects on here, and what this does is that it's takes the Mediapipe-rs library, and then say I want to import 2 things. One is object detector, so that builds the model for the object detector. And then there's the other utility function called draw detection. It's part of the post process. Okay, so so the object detector builder does the pre-processing. It takes the image, the JPEG image, resizes it to the right size and right format, turn that into an array, a tensor, and then send that tensor to the model to process, to TensorFlow-like engine to process. When they get the result back, the result would be displayed both as text, and also the result can be drawn, overlapped into this original image through the draw detection function, right? So you can see it here. You can print the result, or you can say I want to draw detection, but put the detection result onto the original image. That's what I mean by the post processing. As you can imagine, if you do not have a native library assistance, if you want to do that in pure Python, it's going to be super slow, because you are essentially manipulating an image with Python. Although most people actually use some kind of image processing library in Python to do that. But you can imagine, in a typical AI task, you would have a lot of those, and all those, if you write all those in Python, it would be it would just be very slow, right? So here we have the opportunity to write it in Rust, and dramatically speed it up, right? So if you run this, you would have here we said we want to see 2 objects, so detect 2 objects for us. It's a cat. It gives us a score, and then you have a dog, and it also gives us a score. And then when we used the Mediapipe-rs crate to draw the overlay of the detected image on top of the original image, it draws boxes like this, so it uses the image library in Rust to do that, right? So it shows you this box contains the dog, and it has 83% confidence, which is a number that comes from here, right? So this is a confidence level, with 1 being entirely certain and 0 being entirely uncertain, right? And this is 84% probability. This one is a cat, right? So that's I think this is a fairly good example to show you that the amount of pre-processing and post-processing the application has to do in order to do AI inference. So the AI inference is actually a lot more than, say, just to do a TensorFlow, do a TensorFlow inference. And then you have text classification, where, that's where, it gives you 2 tests. I love coding. It's basically a sentiment analysis. It's using a BERT model, right? It tells you whether the sentiment is positive or negative. Also, we have seen this use case with OpenAI, right? That's you give it a paragraph to say is the sentiment positive or negative, and we also use that in our own community management tasks, right? So if we get a comment on the issue, that we would run it through a test analyzer to say if this is an urgent issue, or does it sound urgent, or does the poster sounds angry, that's is something that deserves special attention, right? So it's so the image classifier actually is is widely usable. So in this case, again, you the image classifier, the image classifier builder does the pre-processing. It's the pre-processing is really to tokenize the text. So you break up the text into tokens, and then the tokens mapped into array of numbers. You put that array of numbers into the BERT model, and then to have TensorFlow Lite to process it. It gives you another number back, and through based on the number it gives back, you will be able to interpret whether it's a positive sentiment or negative sentiment. So that's, you can also see that, that's the results say, if I say I love coding so much, it's a 99.99% positive, so it's a very high confidence it's positive. And if it says I don't like something, then it's so, pretty strong negative. Of course, the BERT model can do a lot more than that, but, this is just one of the things that's, that we can showcase here. Again, pre-processing, post-processing, and those functions are built into the Mediapipe-rs script that works with the underlying, TensorFlow Lite libraries, right? And then you have gesture recognition, which is similar to the object recognition, but it's just with hand gesture, right? So it tells you this V for victory, right? With 93% of probability. And then this is an example of FFmpeg, which is that you give it a stream of audio, and it would use the it would get the media stream. And then, so it's fairly complicated, but you can see it. It's, yeah. You can, use the FFmpeg library, to understand the media file, be it audio file or video file. Say a video file, you can extract frame from it. You can do a lot of things with it, right? So you can transform it and things like that. And you use that library to transform that into a into the input that the model can understand, and then have the have the model classify what type of audio, what type of music is that. So let's go back, and it seems it has finished. Let's see. So, we have installed all this, and then we have run the tests, meaning that we have go into each of the directories in the example directory, and then read the test data, pass the test data to the model, and see what comes. So here is building the application. It's a typical, Rust. So, you can see that. You can see the classification results where it's come from the audio, right? So it knows if it's a speech or it's a tick, right? And the face recognition, it's there's, when you do the face recognition, it's recognize the landmarks on the face. The 0.1, 0.2, 0.3, it's 2 eyes, nose, and mouth, and things like that. And you can see, you have different pictures where it detects whether the hand gesture is some up, some down, victory, things like that, and pointing out, and things like that. And yeah, that's all. Those are hand landmark. You can have those say the index finger, the tip, the middle, and that's, so it can detect all those from the image, and then the post-processing functions have the opportunity to draw and overlay on top of that. So that's where you see those videos where someone show up a hand, and then they move the hand around, and then you would have the overlay on top of it, so it can keep track of all those, right? You have, so that's how it's done, right? That's how in a stream of video you can process that for each frame. That's that can be done really, really fast. So there's so this goes on, and so this here is a cheeseburger example. That's and the bagel example, right? Well, this is actually interesting. That's remember that image that you're seeing. It's because we say give us 2 classifications. So it gives us top 2 classification. First is cheeseburger. It's 70%. probable. And then it's bagel. You know, when you think about it, how's the bagel is different from cheeseburger? You know, is that, you know, if bagel has a beef patty inside it, is that a cheeseburger? You know, I don't know. But the bagel is like only 2% probability. So, you know, so everything else falls off really fast. So cheeseburger is far more likely, right? You know, so and here is an example of testing birds. You know, that's you know, what type of birds this is. You know, that's you give you a bird picture, it tell you, you know, so we have all seen those applications where you take a picture of a flower, it tells you what kind of plant is this, and if you take a picture of a bird, it tells you what type of bird it is, right? So yeah, that's it can do a lot more. It can do image segmentation, you know, where it becomes really useful when you have, say, you know, a picture of the road, you want to segment the road, you know, that's crucial for autonomous driving. And yeah, this is a dog and cat video dog and cat picture we talk about. It tells you where to draw the box, you know, the detection number one, where is the box, and what's in it, what's the confidence level. So it tells you all that, and you'll be able to plot it on the original image. So it does all this. So it goes on and on. So you can there's a wealth of information, and you can some of them is in the README, but a lot of them is in the CI. And I really encourage you to try them out. You know, that's things like that are offered as you know, what do they call AI as a service at major cloud providers. You know, so you upload a picture and tells you what it is. To upload a face, it tells you who that is, right? You know, so but I think with the Mediapipe library, we are you know, we have found a way to demonstrate that we can really do that in Rust and also do that in Wasm, and gain a tremendous amount of gains, you know, in terms of performance, and also reduce the weight of the whole solution. And so our goal is that really to go work with our users and our customers to identify which models are the most important for us to support in an ongoing basis, right? You know, I think the Mediapipe set of libraries models are very important because they are widely used in data streaming, but obviously there are a lot more, and we're also in the process of running a large language model inside WasmEdge, right? You know, so we are you know, we are making pretty good progress with a couple of graduate students that we work with to take the you know, the Facebook's Llama model and make them run, you know, to do build the pre-processing functions and post-processing functions and make them run in WasmEdge, so that you can chat with, you know, you can you know, you can have a conversation with those models through WasmEdge, right? You know, so those are the yeah, those are the things that I want to talk about. And then one last thing I want to point out, where Mr. Yuan has also very kindly mentioned, is that he has built into GPU support for that as well. You know, so because when you build the TensorFlow or PyTorch library, you can build the CPU version or the GPU version. So far, everything we have done here is CPU only, because GitHub Action only has CPUs, right? You know, but you can do GPU as well. So if you have a GPU machine, you can just tell it to, or even TPU, right? You know, so to have, you know, to have the appropriate library in place, and then you can, in your Rust code, you can tell it to use those, you know, chips or equipments that you have on your system to achieve much faster performance. Now you have very fast inference performance from the GPU or TPU, and you also have very fast pre-processing and post-processing from Rust versus you know, versus Python in the past. And then you have very small image size, and takes very small amount of memory, and you know, it just allows your system to run just much more efficiently. And I think that's a major pain point in AI and machine learning today, is that all those things are consuming way too much you know, resources, and we need to cut down those consumption. So yeah, that's what I have. So again, you know, really appreciate the work that Mr. Yang has done. That's and please do get in touch. Raise a issue. If you can't make anything work, that's raise a issue in this repository. Otherwise, let us know. This is really an important use case for us. So we'll leave the question to the end, I think, for the moment. And so I asked Hydai to come back, and because we only have 5 minutes before the hour to talk about new maintainers. Hydai, please.
Okay, so I'm going to introduce the new maintainers to join our, the WasmEdge community. So I'm very happy to have this new, very core contributor here and to join us. So the first one is the Aman. His GitHub ID is Hankfish, and you can find his core contribution is to porting WasmEdge on the Android platform. So you are going to, when you are trying to follow the guide how to build WasmEdge on Android, that's all is works. So this is very, very powerful for us. And also he provide the WasmEdge WASI socket CAPI in, so you can just use the CAPI to interact with our WASI socket extension. So this is our first new reviewer today. And the second one is, the person who creates a very, wonderful Mediapipe-rs job. Okay. So the GitHub ID is here, and you can just find it, from the website. And also, he contributed, several very important things. The one thing is that he added the GPU support for the WASI and the PyTorch backend, which is very powerful because, when we are enabling the GPU support, the performance of the PyTorch inference is very, very fast than the GPU ones. And also he fixed lots of bugs in our upstream. So that's why we want to invite he as our new reviewers. Then our third new reviewers is Yuan. And he's provide the WASI login proposal, which is a pretty new proposal. It's still in phase 2. However, it's very helpful if users want to, print some error log. For example, you want to print some log with the error level, print some warning, debug information, and lots of things. This proposal can help. So with this contribution, that's why we want to, promote this contributor as our new reviewer for this component. Then this is our new committer, Shreyas. His previous is our reviewer, and his core contribution is that if you are installer, whatever you use the bash version, you are use the Python version, that's how his work. So I'm very thankful, and with he, we can make lots of people can install WasmEdge easier. You don't have to just download it by yourself. You can just run a very simple command and set up all the stuff that's WasmEdge need. Yeah, so that's our new committer. Yes, and we are still welcome lots of people to submit their PR, submit their contribution, and if you are your contribution is have some important things to do, then we will the community can just promote some of the core contributor, become the new reviewer or the new committer and the new maintainers. So we are welcome, the every contribution to the WasmEdge community, and welcome this new maintainer on board. Thank you so much.
All right. Yeah. Thank you, Hydai. And yeah, that's we are really happy to have to have those I wouldn't say they're fresh faces because we have seen them in the community. That's why they become interns, right? But really excited to have them to become to take more responsibility, and we are really thankful that's for their contributions and for all the contributions from you as well. That's I think we have come a long journey, and we still have a long way to go. If our goal, because I think several people in this chat has mentioned about the use case of using WASM to do AI inference. I think this is one of the use case I see a lot today. That's but as we also see from the work we have done in the Mediapipe-rs, there's still a ton of work that's left to be done, in order to catch up with, say, the Python ecosystem, right? There are lots of things that's, the pre-processing, post-processing with different kind of data and different models, So I think it's, yeah, that's, love to have you guys here. And I think we are 1 minute after the hour. And, so we're going to hang around here. So if you have questions, feel free to ask. Otherwise, we'll see you next month. Thank you.